size change?
Angular
Absolutely.
size has nothing to do with the fucking angle.
I asked a simple question.
No, because you're not talking about the size of something.
Okay,
You're taking
but
the
do you
angle to
agree?
something.
I know you're not talking about the size. Cool straw man, 5-year-old. So,
Angular
what
size
about
is not
triangular
angular size.
size?
hey man,
What about
do
the
you
change in triangular size?
do you account for angular size change?
Who
Yes or no?
gives a fuck what you want to know?
Is this a parent
Seriously.
triangular
Oh,
size?
here we
So
go.
it gets
So
way.
we're talking about
See,
angular
look at
position.
this.
You're talking about the angular position in your field of view.
There you
changes.
go, Sonic.
Xanac.
Bite hard.
There
Bite
you
down
go,
hard.
right?
Sonic. Go
Now
on.
you know.
Moderator.
Now you know.
Xanac.
So
Xanac,
perspective
WITSIT,
does not
and
change
Curve,
the
we're happy to
angular
Not your anal
Let me
position.
finish. Let me finish.
Please don't.
Angular
I'm
position.
Don't
boycotting.
talk about
Verbal
anal
boycotting
I
me
can't
for not
stand
not
WITSIT
boycotting
talking out of
this.
his
This is
ass.
some bullshit.
WITSIT is talking out of his ass again, and it kills me.
Hey, mute
Sorry.
Xanac. Come on,
Don,
WITSIT.
you need to take control.
So
Curve,
Okay.
WITSIT.
So one step at a
Angular-
time, man. You had.
Xanac, you're like the fourth person in line, man. Witzik was talking. Rizzo fucking rumpused it.
Nobody's
Witzik and the other
addressing
dude.
the elephant in the room.
Well, wouldn't you want to actually hear my coherent point first,
No,
instead
you
of presuming
mentioned
what
the
it is?
size.
You don't have coherent points.
We talked about spherical access and
Access.
spherical excess and perspective with
Come on,
regard
Mog.
Okay,
You gotta
okay,
control these
Xanac,
Yeah,
calm
listen,
down.
Kangaroo court.
the
Kangaroo court.
position does not change due to perspective.
Okay,
Does not.
now
Dude,
listen.
Zannick's allowed to respond, man.
I know that, but he just goes a 0 to
Yeah, because
100, man.
everyone talked
And you're
over
gonna-
when he tried to respond.
Yes, I had one
And you're
point
going
to
to
make.
take forever to get going because you're going to whine with all of your fucking time.
Exactly.
Okay,
let me
so
say it again.
you have to
You
account.
mentioned perspective
Look at this, dude.
because I didn't get a chance to say the point without you interrupting me. Let me
I
say it
wasn't
when
even
you talk.
talking the whole
Let me-
time, Xanac.
Let me
Xanac,
finish.
limit your talks to 20 words or less.
Let me 15 seconds, and then don't interrupt me. So you mentioned perspective. You mentioned angular size with respect to spherical excess. Angular size has nothing to do with position, angular position in your field of view, because if you're level, perspective, everything stays at level as it goes further away. So angular size is irrelevant.
Dude, this is crazy, man.
Irrelevant.
Okay,
All
so
right, Don.
the
Don,
first-
respond.
Don't
Wow.
give Dawn a chance to respond.
It's Don's turn.
God forbid I get to
I wasn't trying to
respond.
get in. Curve, stop being messy.
Yeah,
WITSIT just got here.
let's
He's
address
way
some of that.
behind in the queue.
Okay, so instead of again just
WITSIT,
jumping
you're
conclusions.
way behind the queue. Didn't you hear?
Dude,
Sit the fuck
idiots.
down.
He has the floor. Why don't you act scientific since you want to be all cocky?
Don, go ahead and stop.
Okay, instead of jumping to the conclusion of what I was trying to say, man, all I was trying to say is we can all agree that when something gets further away, it changes in angular size. So it would be more productive to at least know the rate of change in the angular size. Is there any fluctuation in that based on atmospheric conditions to get an accurate foundation? In addition to that, because you're then taking the angular position of it anyway, so you're going to need to be accurate with the data. So now that y'all have beat up a straw man and freaked out, would y'all like to respond to my actual point?
Are we measuring the size of something with it?
I didn't say we were.
We didn't
So why
freak
would
out.
you
We
bring up
addressed you
angular
very
size?
accurately and succinctly.
Do you agree the
I
angular...
responded accurately to you, man, that what you're describing right now is irrelevant to what you're talking about.
So you're
that's why
saying that
basically
angular...
literally said it in more or less words.
So you're saying the angular position is
gonna
irrelevant
ask
to its
again.
angular size
He's gonna
change?
ask again.
Is the angular position irrelevant to
Yes.
the angular size
Yes.
change?
Yes.
Absolutely.
Well, y'all are dumb because the
unequivocally
angle
yes.
changes as
Yes.
the size changes.
No, not if it's at your horizontal.
Yeah.
No, if it's exactly at level, an orientation perpendicular to plumb, no,
Hold
that
on.
position will never
Perpendicular
change.
to plumb.
Never change.
Xanac, you got to understand, he lives in a 2D world. There is no difference between the observer and the observation
All right, well,
or the target. There's
something
no
goes
distance.
below you as it gets
It's just
further away.
angular
I'll just show
size.
some
No, we're
demonstrations
not
because
talking
y'all
about
are
below you. We're talking about at your eye level.
Perception, we'll say.
I understand what you're measuring. You're
So
measuring the
the angular
horizontal.
size
You
has
act like you're
nothing to-
teaching me. You're not.
No, I'm teaching
trying
you because you're so stupid. You don't
See,
listen.
y'all just like to frustrate me, man.
You don't listen. So the angular position has nothing to do with the angular size at all.
Okay.
As long as it is level with your the level eye line. with
Okay, we're
perpendicular
trying to
plumb.
establish
Not happening.
level,
Your
man.
level
So
eye line.
With a bubble.
listen,
The bubble
yeah,
level.
but listen,
No.
when something
God
goes
damn it,
further,
Zanuck, you're fucking wrong.
Just take it. Just you already said the information, so I'd leave it at the one you were right.
so when something goes further away, it gets smaller, and it'll look like it gets a little bit lower further away from you, and we can demonstrate this.
Right?
What?
Is it ever going to change angular the position? Angular elevation? No, it's not. It's always gonna
I
be the
never
exact
said
same
it's going to
angular
change angular elevation, Kosho.
You did. You said angular position. You said that.
I said, is the angular position
Related to size.
related to the angular size
No, it's not.
change?
No, it's not.
Okay, well, we can demonstrate that it in fact
no.
is.
At
An example it never
level,
would.
at a level observation, it will not change position.
Okay, so we don't have to worry about whenever, because this is the thing. When we're trying to establish level, what we're going to have to do is look out to the other location and establish level relative to where we're at. That means, objectively, you have to account for angular size change to do that.
No, that's not angular
Right, you know,
size
I'm gonna
change.
go
Angular
to
position
Facebook
change
for a
is
second,
different.
man, 'cause you're not saying anything correct right now.
Yeah, you're just.
That, well,
jumping
y'all can't
over
respond
words, you're
specifically.
Cocksure, though. He's very cocksure.
Okay, so what did I just say, Curve?
You just said that you have to look into the distance to determine if you're level.
Is your name Curve?
No, that's not what I'm saying.
Yeah, it's not
So
fair,
you,
man.
es-
It doesn't matter
you're
whose
such,
name he says,
you're
man.
such a loser, Kosho. You establish plumb, local plumb, and that's how you get level. But then you're looking out at the other one. You're saying the angular size change doesn't matter if you're level to each other. That's what he just said. So that means, how do you establish that you're level relative to one another? How do you do that?
For this angular size thing, it doesn't matter if you're
How
level
do you
one or not.
establish your level relative to the other location? How do you do that?
By getting a plumb and orienting your observation perpendicular to plumb. That's level. That's your
Okay, so
orientation.
you establish local plumb because your total station is
horizontal.
plumbed up,
Yep,
and then
yep.
you're looking at the other location. You're
Right.
establishing the
Say I'm
relative
looking at
nature
that
of the.
mountain. Say I'm looking at that
Wow.
mountain. Say I'm looking at that mountain 100 miles away, and it's right smack dab in the middle of level. The peak of that mountain is level with me.
How do you establish level of the other location relative
Why
to
do I
where
need to
you
establish
are?
level of the other location? Why is that?
So you just said that both parts are both places are level.
I did not say both points are level at all.
So
I just
they're
said
not
if you
level?
no, we're talking about something in the distance that's in your field of view. It will not change angular position at all if
Wow,
it is
you're
at your
scattergunning
level.
and freaking out, trying to
Everything
straw
on
man
your
again.
hold on. Everything at your level, the level you just established, that you just talked about, will not change regardless of angular size.
Oh my
As
gosh.
you farther
So
away,
look,
the
no one
position
can answer
doesn't
the
change.
question. Kosho, can you answer the question?
If it's
Use
on
water
your level.
Zanuck, stop. If it takes this many words to explain it and be wrong, there's no point in doing it. Let's just use
Can
a
I
water
just-
level. 2 words, water level.
Okay, so you use the water level. So is this observation happening over water or over land?
There's only 2 words you get, buddy. If you can't figure it out from there, then
Ha ha. Okay, so
you're
you take
fucked
your.
anyway, man. If you can't figure it out,
Someone's
from that point,
freaking out.
Water level. You can use a water level. It's a
Yeah,
defined water level.
I know. So what I'm saying, in addition to that, are you actually looking over water itself, topography? You're always looking over topography because you people don't understand shit ever. But anyway, that would never hurt your results because there's a glow, I promise. Then, even if you're not looking over land and you're looking over water, you're going to have your local plumb established, assumed perpendicular to the Earth or the horizontal plane. The Earth is assumed to be a plane to establish local plumb. That's how it's plumbed up in a total station. Then you're going to go get your other control point. However, you haven't specified a distance, but it doesn't matter because as it gets further away, the angular size changes. What you do is then you look through your total station and you center it, correct?
No.
You
everything
lied,
just said was
WITSIT.
wrong.
You lied.
Everything you just said is
You don't
wrong.
understand still.
Which part of what I
Hey,
said is wrong?
WITSIT,
All of it. Every last bit of it.
Hold on.
One specific part, then.
Let somebody with an answer say something.
Yeah, Curve can be able to tell you how you got it wrong. Go ahead, Curve.
Get his dick out of your mouth, Mr. Reality.
Yeah, I'm not wrong. None of you can specify.
You speak
No,
as though Curve. You're the one who said Curve.
If you,
I mean,
if
that
you,
WITSIT's wrong.
reality, there's like 8 or
Here
9
you go.
people talking. So if you don't have anything to say, don't say anything.
Hey, I'm saying that y'all need to let Curve speak.
You need to shut the fuck up. Now, WITSIT, listen what you said about establishing plumb.
Yeah,
and
local
it's
plumb.
assumed to be perpendicular to the plane of the Earth.
Well,
is
yeah,
not
when
correct.
when the tool when the total station is plumbed
Yeah.
up, it's locally plumb and it's vertical relative to local horizontal, but
Yeah.
the computer factors in the supposed curvature rate.
What fucking
Exactly.
computer?
What computer?
Local horizontal.
The total station.
What is
What you're
local
talking about?
horizontal?
We did this
What is
in
local horizontal?
Sorry, say again, because y'all are all freaking out.
What is
Listen to
local
everybody.
Look
horizontal?
at them all freaking out.
They're triggered.
What is local horizontal?
Okay, yeah, you establish your local plumb, which is your vertical line you drop to the earth. It's vertical, so it's perpendicular to what?
It's perpendicular to any plane that's perpendicular to it.
Yeah, the local assumed plane of the perpendicular line to
Assumed
the
by
vertical
who?
plumb.
Assumed by
Fine,
who?
fine. A horizontal
Assumed by
perpendicular.
That's
Panic.
assumed by the
Let go.
actual
This is a cheeky
apparatus.
attempt by you to fucking define the Earth flat.
No,
Because
assumed
you
by the
don't
apparatus.
listen at all, Curve. Curve, why don't you listen to him? He's telling you exactly how you're being tricked. And instead of just...
Goon.
Assumed by the
You're not
apparatus
talking-
itself, my friend. In order to ensure the efficacy of the apparatus itself, and it's plumbed up vertical down to the earth, okay? And since it's vertical, it's horizontal to the earth, which means at the time it's plumbed up, it's on both models assumed to be a horizontal plane because even on a ball, it's so small relative
Not
to that.
the Earth.
Now, ultimately,
We're not assuming the Earth is
see,
a
y'all are
horizontal
freaking out.
plane.
Yeah, no, it's
Mute
not,
me!
man.
Go and
What
mute!
is
Go
not
mute!
that
Go mute!
the vertical is perpendicular to a plane that's horizontal at that point.
okay, that's what I said.
Any plane, not the Earth. Not the Earth. There's
Okay,
an infinite
dude.
number of
Well,
planes
you're,
vertically
where
that
are
are
you?
horizontal
Are you
to that
dropping the
goddamn
plumb to the?
at
Are
that
you dropping
point.
the? Are you dropping the plumb to the earth curved?
We
I
don't
thought
give
we
a
were
fuck.
using water level.
Wait, is it plumbed up
Going back
relative to the earth? Yes or
What, you
no?
think it's got to touch the fucking Earth?
No, of course not. Is it plumbed up relative to the earth though?
No.
It should be aligned with
No.
the vector, with the
Not as
vector
you're
of
thinking
gravity
about
at
it.
that point.
Yes, that's right. It's the vector of down relative to the center of the earth.
That's an assumption you're
Not
making.
relative.
No,
to
that's
the
an
center
assumption
of the
y'all
Earth.
make because you think you live on a ball. That's your
No,
side.
Do they?
The sum of all the
Wait,
vectors
center-
will
hold on.
point
Can I
to
say
the
something?
center of mass.
It's not.
That's
Yeah, that's what I
different.
just said.
And it's not
That's not what you just said.
exactly. It's not the center of the earth. It's not the center of the
Wait,
earth.
is the center of mass at the center of the earth?
No,
No.
Oh, where's that?
Stupid.
it's slightly off.
It's slightly off. It's in the okay. The center of mass is slightly off based on topography.
No, based on mass
Mass
distribution.
distribution.
Yeah, mass distribution to the core relative to the very top, all the way
you're
to
so
topography.
confused. No.
See,
You
this
people
is what,
don't understand
there's no
anything.
point in
So
arguing
retarded.
this guy straight
Seriously.
up. He's a fucking jackass clown.
Hold on, can I get
Wow,
something in
y'all
before
are,
I freeze
y'all
my
are
fingers
spiraling.
off? Can I get
That's
something
all
in
they
before I
got
freeze
for
my
you,
fingers
Wits.
off?
Stick needles in your eyes. It'd be easier.
I just did some math, okay? So, like, you can make a globe out of 129,600 flat pieces. So if you divide that with 198 million square miles on this earth, that means a good 1,527.7778 square miles could be possibly flat.
Okay, that's a cool, incredibly cool story. So,
There are definitely areas that on the earth that
well,
are
in
flat.
case you didn't know, the whole
Did you
point
understand
here,
that?
yes,
There are
but the whole
areas of the
point
earth that
here
are flat.
is
They're
what's in
small areas.
contention. Stop. What's in contention
Stop.
is the very dimensions you use to get that figure, my friend.
A plum?
No. The very dimensions the dude just said he used to figure out how much of it could be flat. The very dimensions you had to use to get that value is
you
what's
not-
in contention.
Okay, I have something for you.
Hold on. How do you
This is
make?
it.
You can make a circle out of 360 degrees, right? 360 lines. You can make a circle with a 360 flat surfaces. 360 times 360 to make a globe. You're at whatever number I gave, 120 whatever thousand. The Earth's surface is 198 million square miles.
How do you know that?
198 million square miles divided by.
How do you know that? That's what's in
number that I gave
contention.
up.
That's what's in contention.
I did my own measurement because I've driven across
You measured the
Canada.
whole
Canada's
Earth.
way bigger than the States, right?
This
You do a
dude
rough
measured
estimate,
the
my
Earth.
numbers came out to 190 million.
You
This
measured
is
the Earth?
198
Gypsy, can we
million
ask him a quick
square
question?
miles.
This dude
So-
measured
so
the whole
what's
Earth.
So with it, Do you think there are any plumb lines that you can measure on the Earth that are not parallel?
I always have to just scattergun and you
No,
think
no,
your
no,
home
it's
run
not.
questions.
I'll whip it out. You are stepping on somebody else's.
Plumb is always relative to the center of mass of the Earth's a ball. It's different because it has an angle. That's where you get your arc length.
Hold on. If we all agree that the plumb is straight down, can there be straight down lines with plumb bobs attached to them that can be not parallel and also parallel?
In your little fairy tale where
You mentioned
both
it,
of
by the
them, it
way.
can't be both of them at the same time, but in your little fairy tale where down
but-
is actually just down relative to the center of mass, it's at an angle.
Really, no. Well, why do we measure plumb lines that are actually parallel in some small areas? and
Because the
overall-
Earth is flat.
No. Well, why do we measure some not being parallel then?
Because you get too far away and
No,
then
no,
you start
no.
taking approximations.
No. Hold on. No, I'm talking about local measurements within like an acre, within a few thousand feet of each other.
A few thousand feet? That's a
Yes.
lot.
Okay, a few hundred feet.
Okay, you barely ever see any deviation, and
No,
so
we barely
I know all
often
about
see
what
it.
you're
No, we see
claiming right now.
often. We see often changes over.
Whenever you look at the other plum 100 feet away,
100
right?
feet away, yes.
Okay, you see often changes is what you're
Yes,
saying.
often.
Often it changes.
Yes.
Okay, now
part that
do you know
understand.
now how much does it change, Zanuck?
Why do you want to know how much it
It
changes?
changes barely any at all.
Why does it-
Fluctuates right around parallel because that's what it really is when you're still looking through 100 feet of atmosphere.
Enough to where water pools up and water doesn't pool up. We can detect that.
Remember
You
Black
can-
Swan, Zanuck. You only
Well,
need to show
geodetic
half a month
surveying.
to disprove it.
You guys in the chat.
This is actually this is known. This is common knowledge. For some reason, you're fighting. There are areas on your land.
Do you even know what
by
my
your
rebuttal
house
was,
that
Zanuck?
can determine if they're parallel plumb lines and not parallel. You're asking
What
like
was my
how much.
rebuttal though,
Why do you
Zanuck?
care by how much?
It's so hard to just get
Well,
you.
I'm talking. I was talking.
I
He's
know, but
interrupting me.
make a
Zanuck,
point,
what was my rebuttal?
make a point.
You said if it's straight down and they're parallel, then it's flat. And I
That's
said, well,
not what I said though.
Then you also said by how much? How much are they not parallel? And I said it doesn't matter. The fact that they're not parallel is all we care about.
What was my rebuttal?
He's just distracting you from continuing on.
He doesn't know what the rebuttal is. He doesn't even know yet. He's arguing against something he doesn't even understand yet. That's all he ever does.
The last thing I heard from you was that by how much? And I was responding to
No, but my initial rebuttal was that you're looking through, say, 100 feet. It's not going to change much at all. It's going to be very close to parallel how you established it locally. That's factual. And when it does move a little bit, it's because you're looking to the atmosphere.
No, not atmospheric at all. You know why they know this? Because they can pour water on this area and see it run off or pool up. That proves that it is not parallel. If the water runs off and we measure plumbs to be not parallel, that means they're not parallel.
Zen, I got a question for you. If we're on a frozen lake, okay, and we go 100 feet away, and we establish local plumb, and then we go establish local plumb, and we look at that, are they going to be damn near parallel?
Yeah, the Earth is very big. Things are always very damn
Okay,
near.
so why are you invoking 100 feet then if it's too big to tell a difference?
Because you know, it's funny. You talk about how there's some refraction, so all bets are off. And we talk about there's some deviation. Suddenly, oh, it doesn't matter. You're saying now that it doesn't matter because these plumbs are so close to parallel that it doesn't matter anymore. You're such a double speaker. Seriously.
It's so
No,
close.
you're self-projecting because you invoked 100 feet and now you're saying that you can't even see a big enough difference because the Earth is too big.
Hey, WITSIT, it's so close to flat, but it isn't.
Yeah, exactly. We can see the water run off when it's not parallel.
See the water run off.
We can see the water. We pour the water on this area of cement and it runs off. It's not flat.
Do you think you're doing good?
It's not these are not parallel plumb lines. So
Everyone else thinks he's doing good.
Hold on. So they pull in a geodetic surveyor. They measure the parallel. They make sure that the parallel plumb lines are there and are accurate. Then they pour the concrete. They establish this parallel plumb, and then the water magically doesn't run off.
Zanuck, how important is this point, and what is it?
Because the point is
I feel like this happens way too often, man. Where you guys are going off about nothing for.
No, man. Kosho, will you respond to my rebuttal specifically?
Kosho, everyone would agree that he.
Curve, can you respond to it specifically then?
He started out by saying
20 words.
Zanuck is talking past the rebuttal that was said like 5 full minutes
He's
ago.
talking to me. Shut the fuck up. So Kosho, we start off and talk about all the plumb lines going directly to the center of the Earth. We responded saying it doesn't. Goes to an area around the center based on mass distribution. And then it went into plumbs because that basically graphically shows why and how the Earth is shaped the way it is.
Well, I don't understand those.
Yeah, center of mass is objectively relative to the center of the Earth, you dumb people. And in addition, y'all are being semantical and pedantic and see-through. And what I said was, over 100 feet, would you see any deviation from... Okay, so what are you saying then? It's changing because the Earth's curved? Because literally, less than 2 minutes ago, you said, well, you wouldn't see it from just 100 feet because the Earth's so big.
I didn't say... You said you wanted to see it, like with your eyes. These are things you measure.
Measure by doing what,
It's
Zanuck?
like you measure refraction. So
how do you measure it? Are you using optics?
No, the shape of the Earth is round because these plumb lines
are
not parallel.
Are you measuring them with optics?
Locally parallel. That means that area of the Earth is locally flat.
Isn't it easy enough to just say it in very simple words? If he doesn't get it, he doesn't get it. But
okay, well, everyone that's smart in this room knows Zanuck's objectively wrong.
I'm not objectively wrong. I'm objectively correct.
Yeah, Zanuck, it's easy enough just to say that in every single location there's a unique plumb, and from any other position from that, there's going to be some deviation, and it's going to be
measurable
correlation to the distance.
Measurably not.
Well, it's not going to be because of the curve, though. It's going to be because of the change in terrain.
Because of the curve.
No, it's because of the change in terrain.
Not the change.
Well, you people just lie then. So is there listen, man, you have to establish local plumb and you have to know your elevation, right? And that's your distance above sea level.
No, it doesn't matter.
So when you're going over topography, you don't need to know your elevation. That's Zanuck's claim.
You can have rises in the elevation of a piece of land and actually have less dense material beneath it, and that would change.
That's not what we're talking about. We're talking about when we're establishing local plumb. Do you need to know your elevation?
No.
So you don't need to account for sea level at all whenever doing survey. Okay, so how are you going to know the rate of curvature then? Are you accounting for topography?
When you're measuring your plumb, you're not measuring the rate of
I know that when you're measuring the plumb, you're not rate. I know that because you're then invoking the differential to say you're measuring curve.
Over and over.
Everybody, back the fuck off for 1 second, please. My God. Now listen, WITSIT. Why the fuck would you need to know your elevation? How does elevation affect plumb?
No, it doesn't affect plumb. You would need to know it when you try to invoke, because he's trying to invoke the differential in plumb to claim that he's showing the Earth to be curved.
Now, what differential is he trying to invoke?
He's saying there's a little differential from parallel when you establish plumb and look at it, and it's because the Earth's curved. That's what Zanuck's saying.
Two different points, two different locations separated by distance, not verticality.
Of course.
So your elevation is not a factor in plumb.
No, when you're going to then correlate it to the curvature of the Earth, when you're then going to correlate it to the curvature of the Earth and it's over topography, you need to know the elevation of the terrain.
Anything right now.
Okay, so that I agree, but Zanuck invoked it to say he's proven the Earth curve because he's completely lost.
Correct. He's being purposely retarded.
Done.
Yeah, I didn't say any of that, by the way.
No, Zanuck, there's no need.
Hey, reality. Fuck yourself, reality.
Fuck you, Curved, you bitch.
Curved. Just because Kosho's here stroking your ego doesn't mean you're right.
You probably are gnawing on a sausage
this
right
is
now.
why I wanted
go
come in
go
here
find
because
yourself another woman.
You just seem to,
Guys,
WITSIT's not doing anything, reality. He's just being dumb.
So you established local. Well, this whole room is so funny, man, because Zanuck said that you're gonna look.
Hold on, everybody, stop jumping on top of each other, because then you're gonna start doing like what Brumby's doing and ask why he's getting.
Well, then don't do backhanded things either, then, Kosho.
That doesn't mean that's not invitation to do it as I'm saying.
Well, you do a little backhanded. If he's just gonna act retarded on purpose, well, shut your little mouth then.
Yeah.
Yeah. What?
Kosho, may I suggest implementing a 1 minute timeout for the first offense and increasing that by a minute?
Hey, Kosho, do y'all agree Kosho should be? Kosho should be allowed to say, "Oh, if he's just going to intentionally be retarded, then oh well," and like just be a little gamma and get away with his backhanded little insults, like, and then
Yeah, I
tout
think you should be
moral
able to get away with
superiority
at
in the
least
same
one.
breath. What a clown!
Yeah, I agree. You
Well,
should get
if
away
you
with
were
at
doing it on
least 1
purpose,
per 10.
I feel sorry for you.
He's a mod.
Purpose,
He's
that
a
was
mod.
fine.
This is a dictatorship, not a democracy. There's one rule for us.
Well,
and
damn, you
another
gave
rule
power
for
to
you.
a loser. Or a secret
Don't forget
king.
that.
What a terrible decision making.
Please,
Is there a
just do.
board that made that decision?
WITSIT, just do as Kosho said. Just try and make the effort. Just try and make the effort to make it more of a
No,
conversation.
Kosho is actually like backhanded when he's moderating. He's backhanding me at the same
You're
time.
allowed to do that.
Well,
You're allowed to do
What
that.
a clown show.
Have a good one.
He's
So
allowed
here's
to do that. And you
well,
do
a
that
good
all
one
the
is
time.
he's retarded. That's his response. So anyway, what I'm saying is you establish local plumb. Zanuck just invoked. Zanuck just said use whatever distance you want. I said okay, 100 feet. So Zanuck's saying that over 100 feet we can see the differential in the plumb that we establish locally whenever correlating them from one location to the other, and we can demonstrate that that differential of plumb is actually a resultant of the Earth curving.
No,
then,
I didn't.
Whenever I start,
specifically didn't
okay, so
say
then
that.
clarify then.
I didn't say that. I said this
Weren't you clarify then?
taking things out of context is a problem for you.
Clarify then.
No, I said that
He's
locally.
clarifying your ass.
I said we can see deviations from plumb, a different location.
Oi, Hosho! Stop
We
muting
can
me,
also
Hosho.
see no deviations from plumb over small location. Over small.
Okay, so what does that prove about the Earth being a ball then?
The Earth curve can be proved over much longer observations.
Okay, so why'd you bring up 100 feet then?
Because it came from the original. It came from the original discussion about you thinking that plumb meant to the center of the Earth. That's what we were talking about.
No, you were saying that even at 100 feet you can see the difference. This is being recorded.
No.
So is anyone else in the room going to admit that he's just lying at this point?
I'll admit it. Zanuck, it doesn't take this long. This is why I called him retarded a second ago, and now I'll back it up. Okay? Because what you said, Witsit, was that, or what Zanuck is saying is that at any two positions, just like I said, any two positions, they're not, they're unique in every position. The plumb is unique in any two positions. So from any two positions, yeah, the plumb will be different, and it's going to be immeasurable at close ranges and measurable at further ranges. And you're right. This is because the Earth curves. Now, like you were asking about the elevation. Like, does the elevation need to come and be taken into account because the difference is because of Earth curve, and wouldn't you need to know the elevation to be able to measure that? And that's what I'm saying. That's a retarded. You're going sideways to come at the same conclusion, and that's the problem.
What you talking about?
You didn't even actually address it specifically, man. So, but this is the thing, dude. If you establish plumb,
Brummy jumped in just when he thought.
Okay.
That doesn't mean I was finished. But yeah, so those two positions are different because the Earth's curved. But I don't know why you think that you would need to use the elevation to measure that curvature. It doesn't make any sense whatsoever.
Okay, yeah. So if you use sea level and you're at sea level at both locations, then you wouldn't need to know the elevation. So is that the case?
No, sea level still can have variances as well.
Okay, so you can just have any elevations you want to, and you're going to measure an arc length.
Yes.
But dude, wouldn't the arc length change relative to the location of the second point?
Over time, see, the deviation is only a couple hundred feet over the entire.
Wouldn't the arc length change relative to the elevation of the second point?
You heard what I said? What did I just say?
You're walking past the
I made
question.
a statement and you started talking over me. So what did I say?
You didn't answer my question.
I didn't. It wasn't a question to be answered. I gave you a statement based on what your question was, based on the fact that the Earth only varies 200 feet over the entire planet for flatness.
In elevation.
In elevation, yes.
Okay, so over 200 feet over the entire planet.
On the water, not the topography of the land masses.
Well, there's good thing there's no such thing as a planet, and now you're
flat surfaces can curve and not curve, and actually convex.
Okay, so now we're just doing this over water. Is that correct?
You started what you brought up.
Well,
water,
we have to
so
throw
we're
out
not
99% of the surveys. Then
we can talk about. You got to stop talking over people, though, because it gets everyone triggered. We all start raising.
He can get away with it. You watch.
Here we go. WITSIT. We can measure over long distances where we factor out all the statistical anomalies of this gravitational inconsistency, and we basically can measure the Earth's curve. I gave you the mountains. I gave you the 50-mile and 100-mile mountains. It's undeniable. You'll never measure it any other way that the further mountain, twice as high, is lower than the closer mountain.
Okay. Now I get to talk. So when things go further away from you, they change in angular size.
Yes.
This is just objective.
Yes.
So you're looking, listen,
By how
so
much?
when you establish, shut up.
By
When you
how much?
establish your local plumb, you're assuming that it's perpendicular to the
By how
horizontal
much?
because it's a vertical angle.
No, no.
That horizontal is in fact the Earth. Then you're looking out over vast distances because when you look over short distances, all it does is show, well, yeah, the Earth is still flat. You look over vast distances, most of the time it's always over topography. That's why you globers just want to use thought experiments because you don't want to cite a specific demonstration or observation or measurements, but they're always done over topography. But if they're done over the water, which is the only even potentially efficient way to do it, then you would be looking at over a vast distance. That's what you're looking at, like a mountain that Zennik's obsessed with, changes in angular size relative to the distance, objectively. So then you're trying to tell me that I don't have to account for angular size relative to the distance of all the objects in the observation, but I can tell you that actually the resultant is in fact because of a curve. It's wild.
No, because if you can see, no, so that's why I asked the question: how much does something change in angular size with distance? Do you know?
I don't know the value, no.
That's a very important value to know. I'm surprised you don't know
Okay,
it.
so do you account for the value?
Yeah, I do. Yes. Many times.
Okay.
If you stop talking, WITSIT, you'll learn something. So when something goes further away, when the distance increases, its angular size is directly proportional to that change. Can you repeat that back to me?
Yeah, it's proportional to the change, the distances. I said that already.
Okay. No, you said you didn't know.
I said that word for word already.
I know. You said you didn't know. You didn't know before. You said, I don't know.
Everyone heard me say it, so just keep showing your ignorance. Go ahead.
If something is twice as high as something else and is twice as far away, how large will that object be in your field of view?
Well, this is relative to a variance of factors.
It's a simple question. There's no factors.
So the atmosphere doesn't change the rate of change, is what you're saying?
No atmosphere. Listen, forget about atmosphere.
Well, forget about what we're looking through for now.
Do you understand?
No, I don't want to. No, I don't understand your little hypothetical thought experiments.
I want to make sure you understand the concept.
I don't want to hear your concepts detached from reality.
No, it is reality.
No.
It is reality.
When are you making the observation without the atmosphere?
It has a non-zero sinking value. Non-zero. It always will be looming. Always.
So the atmosphere doesn't change angular size. Is that your claim, Kosha?
Atmosphere does not change angular size.
Okay, so if I go, so if I take a car drives away from me, and then it disappears or it gets smaller and smaller, and then I go back the next day and the atmosphere is way thicker. Is it going to look exactly the same as it did? The angular size is going to change exactly the same as it did before?
It's measurable differences of long distance.
Didn't hear either one of you.
Disappear because angular size. So.
Okay, so the angular size change will be relative to the atmosphere.
It doesn't change for whatever distance it was that you saw it from in either day, it's going to be the same size at that distance. If you didn't see it, it's not because it got too small to see.
Okay, so you're claiming that the angular size change will not vary based on atmospheric conditions, correct?
Not by anything that I know.
Not to a measurable degree. And so
now we're changing. Now we're backpedaling. Not a measurable degree.
The object will be distorted. But hold on, Keisha, I got this. So
try to give short answers, Zanik.
I will. So thick atmosphere, you will have some distortion of the object. Yes. So it'll be a little bit different in shape and size. It's very small.
Okay, so what's the most accurate way to compile survey data?
Make your observations, take your measurements, and then repeat.
In close proximity, right?
No, long proximity.
What's the most accurate way to compile survey data?
I just told you. Compiling.
Well,
taking multiple measurements.
The objective answer is that you do it in close proximity and you take multiple measurements from multiple angles. That's the actual answer.
Okay, so back to the original.
Wait, no. Do you concede that point?
I'll be quiet in a second. I wanted to make the last point, and you can go off from here. The answer to the question at the beginning was if the object is twice as far away and is twice as large, it'll appear to be the same size. Also, let's just leave it right at that. That's easy. That's enough for you right there.
Okay.
So if it's twice as far away, it becomes the same size as a closer object, providing that it is twice as far away.
Wow.
You get that. Now, refraction can only loom something upward. It means the light can only bend down. Why? Because the atmosphere is denser downward always, especially when you're mountain to mountain observation. It never has a substantial inversion where you.
Okay. Do you see the picture in the chat box?
Yeah, it proves you don't understand.
Wait, okay, no, this is the first step. This is the first step.
You
Okay.
don't understand.
No, calm down. This isn't my entire argument. The point is, yeah, obviously everyone understands the simplicity of what's in the chat. So anyway, the way that views that guy right there, the way you view that, right? That is relative to his distance away from you. Do we agree?
The object is what?
The way you perceive that guy right there, it's relative to the distance he is away from you, right?
And his height above the ground.
No, and
Okay, yes.
mainly the height above the surface, which looks like a couple inches.
So the distance is irrelevant, Zanuck?
The distance is one of the factors. The main factor is
okay. I don't need you to tell me what you think the main factor is, man.
The first factor is the observation point.
Okay, so Kosho answered right. Yes, the elevation of the guy and the distance away from.
I said the first is always going to be the observation point.
Okay, so we are just contrarians.
No. The line cannot be drawn unless you know the height above the surface. So
are you going to chill?
It's irrelevant. Nothing has any meaning unless you know the height of the observation.
Okay, that's my point, because the only way you know the height above sea level or the elevation is to take the geoid model and vast distances into account.
Or
no, there's no or. There's no or.
When you listen. Or you establish a horizontal that is perpendicular to plumb. That's the gotcha, WITSIT. That's what you don't understand.
That's the gotcha?
Yes. So the horizontal here, where's the horizontal? The horizontal would be probably at the guy's legs there. See the guy's legs?
I don't need any of your probablys and fairy tales. You're running away over and over. Back out.
Hold on. That would be how you would measure everything in a distance, and a horizontal would not move angular position in your field of view as long as that horizontal is perpendicular to plumb. What you fail to realize is that the observation point starts this line. You need 2 points to form a line. Without that point, you don't have a line.
Okay, thanks. Welcome to Flat Earth.
No, welcome to you being an idiot.
You just don't understand. So when you drop vertical, of course, it's relative to Earth, and that's assumed to be perpendicular.
How high the observer
now
is.
Oh my God, you have.
I would say the height of the observer is probably at that monster's waist.
You have the horizontal.
That monster's waist is probably
learn to make meaningful statements. Learn to cut the argument down. Learn to quit just randomly thinking you're a goddamn college professor and you've got an hour to fucking lecture on a 30-second comment.
Thank you, Kurt.
That's meant to be constructive. I'm going to get a fucking burger.
Add jalapenos and bacon.
He's making a good point though, Zanuck, because you make good points and you're a good asset at times, but you have to know when to stop.
But everyone should jump in and say, I know, I get it, but everyone should jump in and say, look, it's a meaningless and nonsensical argument because we all know that we need
no one gets to jump in because you're always talking, Zanuck. And if you're not always talking, WITSIT is.
Before I go, let me jump in and say this last thing then. Attack the argument about the angular size. Angular size and what would happen if you're measuring. You're counting for the distance to that object, its actual height, and the measured angle to it. And how even though it appears lower in the field of view, you could still measure it properly with the right equipment. Deal with that.
Okay, thank you. At least, thank you, Curved. Oh my God, never thought I'd say that. That's what I wanted to do. I want to talk about the meat and potatoes. So what he likes to do is point at a mountain really far away, right? That's like Zanuck's favorite thing to do, or y'all's favorite thing to do. Look at this mountain over here. Well, this is the thing, man. That mountain changes relative to the atmosphere, to your height, to its height. Now, how do you know what its height is to understand the angle, then where it should be, to factor in angular size, and figure out where it really is? And you need to know its elevation. That means you need to know its distance above sea level. In order to do that over a vast distance, it's significantly different on a globe Earth as it would be if sea level was just literally level on a plane. So you have to factor in the elevation from the geoid model.
Everything you said is wrong. Now I'd like to demonstrate that. Let's look at your little diagram with the fucking dinosaurs and the guy, okay? Are you back on it? Can you look at it for a second?
Yeah.
Alright, so let's say I want to measure the horizontal angle from that guy's head to the peak of that mountain.
Okay.
You with? Can I do that?
Well, as long as you know the elevation of that
Why am I getting muted
object.
yet? And I hardly fucking get to say anything. Can I get muted every...
As long as you know the elevation and distance of the object in the back.
So let's be clear. Let's take this one step at a time. You're telling me that if I want to measure the angle between those two guys from me.
No, yeah, you could measure an angle.
I need more information.
No, you could just measure the angle, of course, man. You're just acting like a child.
So I can measure.
You actually maybe are a child. Maybe that's what it is.
So I can measure the angle between that guy's head and the tip of that mountain.
Okay, cool story.
Do I give a shit about their angular size?
Okay, now that you're not understanding, in order to
answer the fucking question.
Wow, dude, you're such a loser.
Right.
No, I want you to answer the question because you're a fuckwit, and I'm going to demonstrate it.
Okay, ask your question again, bud. Because you're so smart.
Do you give a fuck about their angular size?
Yeah, well, I do because you have to interpret the angle. You clown.
You're interpreting an angle.
Yeah, no, you're interpreting the data that you're then going to use to invoke this angle to support.
Too smart for you lot.
I'm invoking an angle. Is that what
you're trying to drag me through the mud, but it's ironically you're just falling all through the mud.
I'm being extremely precise. And I'm asking you to answer specific questions. So can I measure the angle from that guy's head to the
I
tip of
already
that
said,
mountain?
yeah, you can measure the angle, but pertinent to the discussion, and in order to interpret the data, you need to understand the distance and elevation to the objects that are in question. You're supposed to be invoking the angle to prove curvature. You're way behind.
Do you have to machine gun bullshit? Can't you just have a conversation?
No, because you're so far behind, you're not going to talk to me like you're smarter than me or something.
No, I am light years ahead of you.
Yeah, for sure. You're a genius. Can we move on from this guy?
He's too smart for you.
He's actually a lot smarter than
We hear the argument. He wants to make the argument for him so that he can.
Do I give a fuck how far away those objects are to measure the angle between them from me?
I already said no.
Okay, so everything you've said is entirely irrelevant to this angle measure.
Well, no, because pertinent to the discussion.
It doesn't matter whether you give a fuck or not.
This guy's a moron.
If you don't know the distance.
Well, you can just take the apparent location and try and guess an angle. That's what he thinks makes him smart and us stupid, apparently.
Not guess an angle. You can measure the angle by the
based on the apparent location.
No, the distances to them.
Okay, so you do need the distances. Thank you. Zanuck disagrees with Mr. Smart Guy.
If you want to know the angle, you have to know into the 0 point. All you need.
So you do need to know the distance to the object.
The entire galaxy is stuck in the accretion disk of a black hole, and space is a reflection of the fucking space behind us.
Just imagine, thinking that this guy's coming in here schooling me right now. So, you got to know the elevation of the object to claim that it's proving curvature. You're scared to talk about the meat and potatoes of the discussion.
All you need is a plumb line and a...
Zanuck, can you shut up? Zanuck, shut the fuck up.
You know we are stuck in the
one wants to
accretion disk of a black hole, then. Come on, tell me how you know these things.
Zanuck, take
Hey guys, can I just ask you a question? What are you measuring? What exactly are you measuring?
You have the distance, and you know the height of that person.
You have to do
the
that.
height of the object away from you.
Yep.
So you're going to draw an arbitrary line.
That's a fact.
To that distance.
You have to have the elevation and the distance.
No, you don't.
All right, man.
The elevation is the top of the guy's head. So if he's 6 foot tall, the elevation is 6 feet.
What's the elevation of the mountain?
You don't need the elevation. That's what you're trying to find out.
Okay, so you're gonna figure that.
Okay,
you're gonna figure that out by using the apparent location of the mountain.
I'm 6 feet tall.
So
I am standing,
my point is
let's say, 20 feet away from a house. From the top of my head straight out to the house, 10 feet away, is a straight line, and then you draw a line up, and that's the vertical angle up to the top of the house.
Okay, but things change in angular size, so in order to understand the angular size relationship...
We're not talking about angular size, we're talking about the height.
You want to ignore that it changes in angular size?
No, we're just talking about the height of the mountain, or the height of the house. We're not talking about angular size.
The height of the house.
Yes,
it depends on distance.
Yes, can you get the height of the mountain?
It depends on the distance. If you're talking about your next door neighbor's house,
and the answer is you can.
If you have the distance, right?
If you have the distance and the observer's height, you can get the
measure amount of
Okay, so at like hundreds of miles away, you can look at the apparent location and not account for angular size change, and then you can figure out based on the angle of the apparent location an actual physical claim.
I stand.
What do you mean we're trying? This is such a fake fairy tale that you're talking about. You said we're trying to figure out the elevation. That's not what really happens in the real world. We know the elevation. We map it on a geoid. We look 100 miles over there, and then we get the arc length. You people don't even understand what's going on right now, dude.
Pretty simple. It's pretty simple.
I agree.
I do not know the height of the house, but I know my height and my distance away from that house. I can figure out how tall the house is just with those two numbers.
Using planar trigonometry?
Planar. No, just regular trig.
Wait, so you don't have to. There's no difference in planar and spherical?
Spherical trigonometry.
I'm using trigonometry, planar trigonometry.
You're using triangulation, right?
Exactly.
Yes, I'm using.
Is it the same on a plane as it is on a sphere?
I'm not playing your word game.
Because you're wrong.
You're red hot, my man.
You're always wrong.
Exactly.
Just chill out.
I know my height. I don't know the height. I know the distance away.
No, he's wrong. Okay, if he sees it visually, are you using planar or spherical triangulation? He said it doesn't matter.
If I'm seeing the house, I'm using my eyes.
It does absolutely
I'm
matter.
not using any type of math to look at the house.
Oh my gosh. You're using math, right? You're using triangulation, right?
Said, are you using math to look at the house? The answer is no. I'm looking
Well,
at the
to
house.
triangulate the points, you're using math, right?
My height, and I know how far away I am from the house.
And then you're going to use that information to triangulate, right?
Yes, and the point is I can accurately get the height of the house.
Okay, is there? Yeah, assuming planar, planar
trigonometry.
Trigonometry.
Yeah, planar trig.
Nope, just regular trig.
That's planar trig.
No, just regular trig.
No, you got spherical trig because you point to your other point.
Just agree that you guys are saying the same thing at that point. There's no.
No, we're not saying the same thing. You want to skip over the implementation and assumption of spherical trig.
Word salad. I am using
I'm not
trigonometry.
saying word salad.
There's no such thing as, in this context, there's no such thing as spherical or planar trig. It's
There's no such thing as spherical or planar trig.
He said in this context.
But he's wrong, Jim.
He's not.
Oh, no, he's not.
It's on a regular trigonometry. There's no need
No,
to
it's
put
just
Okay,
trigonometry.
so that means
It
planar.
doesn't require any other. Well, it doesn't require that. It's
Well, yeah,
trigonometry.
because we're talking about.
When I was
He's
at
saying
school-
this
when
is
I was-
analogous to proving the Earth is curving.
When
Are
I
you
was
not
at-
listening?
When I was at school, I learned trigonometry.
Oh my
wasn't-
god!
Shut up! It wasn't planar trigonometry. It was trigonometry.
Yeah, which
And
is planar.
And what he has just described is trigonometry.
Planar trig, right? So how is it
No,
analogous
just
to
trigonometry.
proving the curve of the Earth?
I don't know where he was going with that.
Okay, well that was my point. So thanks for the high school
You're making
story.
the point.
Of the mountain or the
You've
height
just
of the house.
said something incorrect.
No,
That is
he's trying to point out to me of how you can use
Moving the
planar
goalpost. We're
trig.
talking about the height of the mountain or the height of a house. We're trying to
No,
figure
I'm not
those
moving
things
I'm not moving the goalpost. What I've already said is y'all are trying to pretend that this is somehow analogous, but it's not, because what y'all are saying is you're looking at the mountains in the distance. We know the elevation. You have to factor in the elevation to postulate it as if it's evidence of a sphere Earth, and y'all don't even understand that.
Doing? What's the elevation doing?
The elevation over vast distances is different. The vast distances make it different, right? Because on a plane, its elevation is distance above sea level, right? Just assume to literally be level. Over vast distances, elevation is actually relative to the center of mass on a ball. It's different. We have a model for it. It's called the geoid model.
If I assume,
Pretty
hold on,
flat when I look at it, but you know.
It's always flat, of course.
Let me clarify something. WITSIT. If I assume my feet are zero, the bottom of my foot is zero elevation, and the bottom of that mountain is zero elevation, I'm looking at the mountain. I don't know the height of the mountain, but I know the distance I am away from it and how tall I am. With those three things, I can get the height of the mountain pretty accurately.
Okay, well, that's cool. Pretty accurately, based on the apparent location that fluctuates in angular size proportionate to distance.
The location of the mountain itself does not
We
move.
just can't know anything, can we?
No, it's not that we can't know anything. I've already explained how
we just
No.
don't know the heights of mountains. We just can't know that. There's no way for us to
No,
know
this
that.
isn't even relevant because whenever you invoke this, what you do is you look at a mountain. You people don't even understand your claim. You look at the mountain and you know the elevation of the mountain. You're seeing what the mountain looks like.
That's what I'm
Well,
Okay, so
according to you, we have no way of knowing elevations of
Wait,
mountains.
no, we do. It's all relative to sea level.
Okay, how do we determine that?
Well, the sea is level.
Right, but how do we determine the distance of the top of the mountain from the level sea?
Oh, yeah, we measure the distance.
But wait, using what method?
Well, it wouldn't be looking from hundreds of miles away
but
doing
what
anything.
method? No, but my point is, you have no method.
Yeah,
So
people
what
have
is your
climbed
method?
mountains and gone to the top of them.
Okay, but how does that tell you its height above sea level?
Well, you would know your height at the point that you reach the top of the mountain.
How?
At any type of way, man. You're such a loser.
I'm asking you what way?
What is your point?
You have no way. You don't.
I have no way.
This
You
is
read-
the way.
you read- Listen, you want to hear my point? You reject all the ways we have of knowing the heights of mountains. You've just spent an hour arguing about how the angular size will change with the atmosphere, and we just can't know it.
No,
So
that's not what I said. That's not what I said. What I said was it's gonna.
matter.
You're just straw manning me like a 5-year-old.
Asking you how you can know the height of a mountain. You cannot tell me. That
Yeah, I
should
said we can
bother
climb
you.
them. I said we can climb them.
And how does that tell you it's height above sea level?
How we could know how high we were.
Hang on. How does that tell you it's height above sea
How
level?
about this? You could just fly in a plane past the top of a mountain. You know how high the mountain was.
How?
Loser. Because you know how high the plane is.
He did say that you
Right,
cannot
so-
know if you're several hundred miles away.
So you're happy with the altimeter in an aircraft? Is that
Sure.
right?
Sure.
Right. And yet, so aircraft in many places in the world have to fly over the top of mountains, right?
Sure.
And they have to use their altimeter to do that.
What are you talking about?
Well, if you're happy that they use an altimeter to fly over the mountain and they're doing it successfully, that would indicate that we know the height of the mountain, right?
Yeah. Dude, you're just trying to obfuscate, I guess, huh?
Already.
You're scared to hear the truth, I guess, huh? So what they actually do is they look out at these.
What truth is it that I'm scared to hear?
Okay, I'll tell you. You think that this proves your religion of a magic cartoon spinning ball when you look out at a mountain and you assume that, oh, look, this is happening the way that we perceive
Let
this.
him speak.
I think that this proves that you have no way of knowing the height of a mountain.
Okay, so actually triangulation is efficient in the sense that it's useful. Is it entirely accurate? Well, in order for it to be entirely accurate, it requires the actual location. As you increase distance, you decrease accuracy. But we didn't do that when we figured out elevation. We mapped it throughout the world, throughout the ages, right, relative to sea level. But sea level is different on a geoid. It's relative to the center of mass. So to prove your quote-unquote true representation of nature that we live on a magic cartoon spinning ball brought to us by Jesuit priests, y'all look out at the distance, hundreds of miles at mountains, and then you tell me that the reason this is literally what I'll say, this mountain's actually higher and taller than this one, but why does it look like it's lower or whatever?
Can we know the height of mountains or not? Can we or can't we?
Yeah, we know the mountain. We already know the heights of mountains.
Right, how?
Well, what does that matter relative to you claiming this proves the Earth's a ball? You're scared to talk about the conversation because you are a loser.
I'll tell you why that matters. Because every time someone presents to you these methods we have for measuring the Earth and its figure, you reject them. You find reasons to reject them. So I'm wondering, as this is part of it, I'm wondering how you determine the height of a mountain. And
I'm so glad you asked.
You can use triangulation.
I don't think you have a way. I don't
loser.
think you have a way because you've rejected
No,
them
what I
all.
said
So
was triangulation is effective whenever you're not increasing distance because that decreases accuracy. You have to have actual location for accurate deduction of altitude or elevation.
What's the cutoff point? Well, at what point does it become inaccurate?
I don't know, but I wouldn't want to increase it because we know I talk to people that do surveying and they say that like you don't want to go very far at all. So what you would do is do it the most accurate you could. You get as close to where you can see the entire mountain.
He's not answering the question, WITSIT.
No.
What accuracy
He's
level
not
are you
answering
looking
the
for?
question, and I'm so happy someone else brought that up. If he used the same thing on us, he'd go back to why aren't you answering? Why aren't you answering? If we
I
asked
stopped
you,
that. I
how
don't
did
know.
you come up with it? You fucking diverted right away.
I said we've climbed mountains and we know the altitude. And
Flying with airplanes and altitude from them. And
I've named 3 different ways. I've named 3 different ways to measure the mountain. This is all your little gamma's attempts to obfuscate away.
You haven't named 3
You're
different
scared your
ways.
religion's not real, I guess.
You said you can determine the height of a mountain by walking up it.
I said we can climb
how.
it.
I said how, and you couldn't tell me how.
Because you're acting like a child. I said you're acting like a kid. When you climb to the top of a mountain, you know how high it is. Are you just you have an altimeter with you?
What if you don't have an altimeter?
Well, that's what people did when they climbed the mountains to see how high they were.
Mountain people don't have altimeters.
Right.
Okay, so no one ever climbed the mountain and tried to figure out how tall it was.
So we can determine the height of mountains now using handheld altimeters, is what you're saying.
Well, yeah.
Until then, we could.
No, I named other ways. You're just such a gamma. You want to strawman me again, but it's being recorded. You live in such a world where you don't even care that it's being recorded. You don't even care.
So what are the other ways? We can use triangulation if we're not too far away, but you can't tell us what too far away is.
Why would you use triangulation?
Ask WITSIT. He says
well,
it's
that's a methodology of calculating the elevation. That's not measuring it either.
He can't tell us what distance.
I understand that.
Okay, so what was your third way?
You're a clown. Oh, okay. Then I said you could just fly a plane right close to the peak, but just obviously you're not going to hit the mountain. You'll fly it beside it, and you'd know how high the mountain was easily.
But planes do that all the time.
So I answered your obfuscation attempt 3 different ways. Now let's move back to the actual subject that you can't answer. That's why you spiral.
Okay,
because you're afraid your religion's not true and it's getting exposed.
If we use handheld altimeters, that gives us a plus or minus 5% bar on error.
Okay, so what you do is you take all the different methodologies and you try to determine the most accurate figure by factoring them into one another. And
so
you factor in the error rate.
Until the invention of the aeroplane, we had no way of determining the height
Did
of the
I
mountain.
say that?
Well, you haven't.
You're actually so lame, bro.
You haven't listed a way that was possible before the invention of the aeroplane, have you?
I said you could triangulate. I said that you could climb, and I said that you can fly. So you're annoying, and everyone here probably knows that you're annoying. I guess that they don't call you out because this is your server or whatever.
With the triangulation,
you're a child.
You've spent an hour arguing against the use of triangulation and telling us, "Shut up! I'm speaking."
You're strawmanning me.
The way.
And telling us how inefficient it is and how we can't use it. And now you're saying, well, yes, you can use it, but only at a certain distance. But you can't tell us what that distance is.
Okay,
I mean,
so
you must see the confirmation bias here.
No, there's no confirmation bias. This is where you will 100%.
I'll reject it when I don't need it.
You're such a loser.
No reasoning whatsoever for why I've rejected it.
Dude,
I'm
drink
just
a beer
reject
or something, dude.
because it's too far, and nobody knows what too far is.
You're spiraling.
Wow, WITSIT really lost that point, didn't he?
Yeah, big time. So
you did lose that point. Big time.
Yeah, big time. So anyway, so what is actually said is that whenever you are closer, okay, and you're looking through less of the atmosphere, so you've had less angular size change and you're looking through less distortion, you can have a more accurate deduction of elevation using triangulation. Of course, that's planar trigonometry, triangulation, right? Now, when you increase distance, if the Earth is in fact, a ball, then actually at a certain distance, because of the convexity of terra firma itself, you have to then invoke or implement spherical triangulation because you'll have an arc length on the ground itself. Now, if you people don't understand that, That doesn't make me dumb. In addition to that, when you're going to pretend to invoke some observation of a mountain in a distance to prove that in fact the Earth is curving, you need to know the elevations, the relative elevations of the mountains, your elevation, your distance between the first mountain and the second mountain, and the entire distance. And you must compare the observation based on those factors. You people want to skip over the fact that in order to determine elevation at a distance that you are invoking, you must apply the geoid model.
No, we can just look at plumb lines and see if they're parallel. If they're not parallel, the Earth's not flat.
Okay, so you're disavowing the other ones that we've been talking about. Now you're saying if we look at plumb lines
No, I didn't reject anything. I just said that's something we can do to see if the Earth is flat. If we take two plumb lines a distance apart, if those plumb lines are not parallel, then we got a problem.
Okay, what distance?
I think probably about 1,000 yards would be pretty good.
1,000 yards?
Oh, do you want it in meters? Sorry, I was.
No, 1,000 yards is a ton. That's a ton.
Yeah. What?
Okay, so then what's the
It's a big ball.
What's that?
Yeah.
What's the
so
window? What's the window of fluctuation?
So then I'd split that into two halves. So I'd do like 500 yards and 500 yard observation, and then go from there. From what I've seen of people, I'm not a surveyor, but that's what surveyors seem to do.
That's not what they seem to do. They don't do anything over 1,000 yards, dude. Nowhere even close to that. I've talked to many surveyors. They say 2 to 250. You're not going to get accurate results.
You can say that there is a limit in surveying, and they can't do this. Produce the citation.
No, that's not what I'm saying.
Because you keep misrepresenting.
No, they try to do it, but they have to approximate because it fluctuates. This has nothing to do with anecdotal. This is factual.
Bring a citation.
Are you disputing the very methodology they use?
I don't know because you've not brought.
Yeah, you don't know because you just don't. You're freaking out, man.
I'm not freaking out, Lipstick. I'm just holding.
Yeah, you are.
And you don't like it.
No, you're just not letting me.
Hear it in your voice.
How am I? No, you're self.
I realise the fact that you live on a globe is a problem for you, and you wish to deny it. But please carry on.
Okay, so now that the loser just stroked his empty ego,
Did you have the
fact is that you're saying a differential in the fact is you're saying a differential in plumb is proving that the Earth's a ball. So I said what distance? Then you said 1,000 yards. Then you said 500 yards. Then now you're saying 1,000 yards again. So 1,000 yards. What's the? No, I'm just going to talk over you. This is what you're doing. So yeah, when you look at the plumb differential. What exactly is the window of the plumb differential readings?
I'll just basically listen for other people not talking, but I'll keep you on like about 3% so I can see your ring go.
I'm finished now. Yeah, so this dude had no intentions of actually. See what he did? See what he's trying to do?
Why are you engaging with children? I have no idea.
That's ridiculous.
WITSIT, you didn't talk fast enough, therefore you're wrong.
Wow, that was a creative come back there. You really knocked it out of the park, bro.
So, WITSIT, you were again called to prove your shit with citations. Can you do that?
Which claim exactly?
Let me know when he brings the citation. I'll come back and read it.
Which claim exactly do you want a citation for?
Ross was asking, so it's up to you if you listen to it.
Okay, you have no idea what you're talking about, per usual.
No, I'm asking you, did you listen to the conversation that we were
he didn't specify either. That's why you don't even know what it is.
No, he actually specified. So did you listen or didn't you?
Then what was it?
If he specified, then why didn't you hear it? See,
that's what you should be asking yourself.
It's not my problem with it that you didn't listen.
So he didn't specify. You're saying he did specify, but you can't.
In other words, you're in a corner because you didn't listen.
Guys, are y'all going to let this go on? What happened to Mr.
I didn't hear him either, so maybe he can repeat what he's looking for as far as citation goes, because I didn't hear either.
I don't want anecdotals of he's spoken to loads of surveyors. I want him to produce a document saying you can't do this. There is a limitation to the distance that you can survey over.
Okay, I didn't say that though. That's a straw man. I didn't
about it, but never produces shit.
But I didn't say that. That's a straw man. I didn't say you can't do distances over this. That's such a straw man. And now you're going to interrupt me and not let me clear. Watch. There you go.
You said that you
can't
have two plumb lines over 1,000 meters and measure if there's any deviation between those parallel plumbs.
No, that's not what I said either. So you're behind too.
That's actually what you said.
This is being recorded, pal.
And then he said, produce produce something that says they can't be done.
That's not what happened, actually. So
he says you
what
can't do it
happened?
accurately. The most accurate way is to do it within 200 feet or so. That's what he said. I was listening.
Yep, and
Oh, you
then
were.
if
Now
you're gonna do
everyone
it
was
over
listening.
if you're gonna do it over a vast distance to supposedly prove curvature, because you don't even see a differential until you increase distance because the Earth's a ball and it's so big, but y'all don't understand your own religion. So then you have to tell me what. See what y'all are scared to hear me talk, man. So you have to tell me what the window of error is. What's the fluctuation in reading? It's not the same every time. It fluctuates constantly. You take numerous readings down, right? So what's the fluctuation error? What's the window?
What is it?
I'm asking you. Y'all are invoking it.
I'm
Tell me it
asking
proves
you.
the
I'm
Earth's a
asking
ball.
you, Witsit.
But this is y'all's claim.
Yes, but
You're
I'm
saying-
asking you.
You're saying.
But this is your claim.
You're saying no.
Yeah, but I'm
No,
asking you.
I'm not saying nuh-uh.
Yeah, and then you're saying that can't be done. Show us that it can't be done then.
No, that's not what I said. What I said was you're saying that you're determining the differential in plumb by 1,000 yards. So I'm asking, okay, when you went and made the readings, you take numerous readings down. What was the window of readings? Because you don't get the same one every time. You never get the same one. It constantly fluctuates. And then you take a mean. So what was the window?
As WITSIT has no tolerance for surveying, I have no tolerance for people that don't show the level
Then
of
go on
time
mute.
required.
We're talking about surveying.
Yeah, and tolerances are very important. That's why I want to know what the bar is.
It's very easy just to press the mute button. Just go on mute.
Because Twitsit over here, or Witsit, is invoking that bar to say, I don't have to listen to your measurements.
No one's listening.
That's not
Oh
what he
my
said.
gosh. This is so
That's not what
desperate.
he said. He
At
said when
all.
you get over a certain distance, the
Yeah,
measurements get inaccurate, and you have
What's
to
that
take
distance?
a mean. And he's asking what the window is. What's the distance? Shouldn't y'all know that? It's y'all's claim.
If he said
It's not my
1,000
claim,
yards.
It's the claim he's making, Rack.
No,
I'm
that
asking you
dude
to
said
demonstrate.
1,000 yards.
And he's refusing to produce any form of citation to say it's an issue.
Guys,
Your own
So
surveyors come over here and tell you
Who
that
said
200 foot is roughly the most accurate.
Yeah, that's for if you're doing.
Why does
sort of
WITSIT
level-
have to
Sorry.
cite anything when your
Can I
own
actually finish?
surveyors
Can I
on
finish
your
what I'm saying,
side
Rakia?
state the very thing he's
Rakia?
stating?
Yeah, can I just sort of finish what I'm saying?
You can do whatever you want, but you're not listening.
Like the people on your side, y'all just disagree with anything I say, I think.
No, we just smell the bullshit crap.
Oh, so you do just preemptively disagree with anything I say, even though it's
not at
things
all.
that people on your side agree with.
That's what
Plus, these things have already been cited to y'all on this channel within this week.
Yeah.
And y'all are asking for it again. Why is that?
Diversion attempt.
I guess so y'all can deny them and strawman them again.
Yeah, just we'll try to divert the conversation away from productivity and coherence.
No, I'm just asking you to back up the shit you're saying.
Well, that guy jumped in and said, we can prove the Earth's a ball because we can see the difference in plumb. You must not have been there.
Hear and still resonating on what
What
frequency?
we can do is see the difference in heights and mountains, which was the entire core of this conversation.
Okay, so
because
now
we can
you
see
want to
those
go back to the mountains.
Because we can see those differences, it's real obvious.
Go back up the mountain with him. I knew there was something going on with you two. Now get on your horses and get back up that bloody mountain, will you? And get it over with.
This is so funny. Wait, time out. The guy jumped in. We talked about the mountains for a long time. Then the guy jumped in and said it doesn't matter because we can look at plumb and see the difference, which is what the geodetic surveyors said in the debate. So that is your stance. This guy's just freaking out. So if you think that's true, then let.
Show you his plums. There you go, mate.
Oh, man. I guess it's almost my time to just get out of here.
This is y'all's channel, right? This is what y'all do. This is it. It's recorded every day. This is the same series.
Exactly.
It's about time for Jim or Curve to come in and obfuscate and tell people they're retarded.
Yeah,
Come on.
when you leave,
We kind of
WITSIT,
know
it's
the
just
script
gonna
by
go.
now.
Yeah, it's just gonna go back
You
to.
don't know what
name
atomic
calling.
particle lines are. You don't even know how to fucking bend lights. What are any of you talking about? Nothing. There you go.
Maybe hire a couple more drunks to come in here and obfuscate the points.
Sorry, I'm not
If
drunk,
you
Rakia. I don't
brain
drink.
cells and a bit more fucking research, you might learn something.
Okay, well, that was a self-projection.
Most of the drunks are actually
I don't
on
need
the
to
flat side.
project. I'm a smart bastard, all right?
Okay, so
As
anyway,
all
when you're looking at
say.
when you're looking at plumb through vast distances, you're not going to get like a definitive reading, and this is known and accepted within geodetic surveying because you're looking through the atmosphere, bro, and it constantly changes. So what you do is you take a whole lot of readings, and then you're trying to try to get a mean because it's constantly moving, and you're trying to. So you center it, but where you center it constantly changes because your optics change based on the atmosphere, hour to hour, and then day to day. But sometimes people just do one day of compilation at a location, typically with geodetic surveying, and then they look at this plumb and they're trying to get the average throughout the day of where it looks like it is because it changes so much. They take a mean, typically a weighted mean, and then they figure out where they think it
Do you
is,
think that we
and then
can
they
work
compare
out the
that to the
standard
radius
deviation
value.
of measurements based on the distance of what they would be from the mean?
Say again. You just aren't listening clearly. You're ready to say something before I say anything.
He's the one not listening. Why does he have to be the one to repeat himself to you?
It reminds me of your debate there, WITSIT, where they're not really listening. They just want to go ahead and.
They have predetermined what they said they're going to say. Yeah.
That's what it seems like. I even mentioned that on here. So that's what I saw with the main surveyor. It's like he's not listening to what you're saying. He's already got something else in his head that he's going to teach you because you just have no idea what you're talking about. So therefore, he has to teach
They
you.
already know it all. They already
Yeah.
know
No, I
WITSIT is
don't.
dumb.
That's what it seems
They
like.
cut us
That's the
off like
attitude.
just now. I just started talking. The guy cut me off. They already know it. They know we're stupid. We can't be right, and they know it all. That's it. That's the conversation. That's how it goes.
And then psychoanalysis, of course.
No, you could be right. The point is you have no evidence that you are right.
No, we have nothing but evidence. Like, you have no evidence of the globe Earth. That's why we're here. That's why you're on a server pretending that's not the case diligently and zealotly.
With it.
It's actually the whole point why this server even exists. Talking about flat
Cool
Earth.
story, bro.
Yeah, I mean, how would flat Earth even be in the title of a server in 2020 if it wasn't the case?
Because some people are idiots.
Oh, so
Yeah,
everyone that
which
thinks
ones?
that everyone that thinks that the model they told us isn't right is an idiot. Is that your claim?
Without evidence.
Yep.
Yeah.
Oh
That's what
wow.
I'm talking
Well, if
about,
that's the
Witsit.
world y'all want to live in, I guess.
Just
That's
throwing
the world
a
we live in.
nice
And
page.
you just
text
convince
in
yourself
the,
that we're stupid. Okay.
Yes, you are.
I know we all want to get away from the details because that's obviously where the pain lies.
Yeah, I know
But
you're self-projecting because when you go to the plumb, then you have to take
haven't
a
even finished
fluctuation
my
window.
sentence, Whitsick, and you're already over talking me.
I'm just reminding you
So-
what the actual subject was. Go ahead.
So what I put in there is the way we can look at standard deviations. Yeah, so when we take measurements, this is kind of the type of shit that we do. So I'm just wondering what your view is, because, you know, if we've got this error bar that's increasing by distance, we should be able to work it out. Is that not fair?
Well, yeah, so I agree. There's an error bar that increases with distance. Yeah, and then you can factor in that relationship. Yes.
So you're saying that we can't work out what that error bar is?
No, I said we can factor in the relationship and we can have an approximation of the error bar. Yes.
Yeah. So we know that the result will be within that range.
Well, sure, yeah.
Yeah, because that's what an error bar is. So,
but even within the range, it isn't mean that it can't be parallel. Like, parallel is within the range.
No, that's the point with the measurements that the main surveyor took, is they weren't within the range.
No, but your predetermined window is.
He put up his error bar, and his error bar was 10% of his result.
So you're not understanding, though, man. Like, for you're jumping past.
Statistics.
You're jumping ahead, man. You just brought up that they make an account for the change over distance.
Mm-hmm.
So that's correct, and they have a window that they come with, and it's proportionate to distance. They have a window of error. Within that window, before you start taking your measurements, parallel is in there. And then you start taking your measurements. That's how that works.
And your measurements have an error bar, and the result is going to fall within that error bar, isn't it?
Well, it depends on how you take it. Geodetic surveyors do it differently. They don't all do it the same. It depends on how they take their mean. Some people weight their means differently, but like if you get something that's way outside of the expected values, then you don't give it much weight. You take a weighted mean.
Oh no,
You
no, not when you're doing
That's
this type
not
of
how it works.
No, that's not how it works, man.
Either way, let's just say you take an average
when you're
then,
looking at
just so we
standard
don't argue
deviation.
semantics,
That's
because
why
I don't want to do it. I don't want to do it. I don't want to do it.
That's why I specified standard deviation.
Right. That's just that's approximation
deviation.
of a window. I've already addressed that.
Standard deviation.
It's the standard. Yeah, we get it.
Standard deviation. No,
No,
you're just
it's not
picking up a
the
word out of the definition rather
It's
than
so
actually
funny.
It
using
has
Yeah,
meaning.
there's a
Please, Witsit, let me
standard
just-
of assumed
value of a standard
fluctuation within the deviation.
what is a
Objectively,
value?
see, Zan's
What
going
is
to
the
come in and try and
value?
derail it.
No, what is the value of a standard deviation? It has a value, by the way. What is it?
Okay,
What's one standard deviation?
I don't care.
You don't know. This is how fucking stupid you are. You don't know.
Wow, see, this is all y'all can do.
Let's not call people stupid. This is
No,
not
all y'all
fair
can do is
because
come in and ask
I
some
don't
random
think you're
question. If
stupid,
Austin
Witsit.
doesn't know
On the
every single
record.
thing in the world off the top of his head, then
Yeah,
he's stupid,
exactly.
even though he's actually provably smarter than you people.
On the record, Witzik, I don't think you're stupid.
No,
okay?
it's
Let's get
it's
that
not really
clear.
an opinion thing, though, right?
No, it's not. It is an opinion because
No,
I
there
don't
isn't
know
an
if you're
opinion
stupid or not,
related
but-
to mental competence.
Yeah, but that's
It's
absolutely
objective.
fine. But
So go ahead.
What I'm saying is just with standard deviation, when we're looking at error bars, the result has to fall within the error bar. That's how the error bar is made. The error bar is made from the variations in the results that we're getting. So that's why we're taking multiple measurements.
Okay.
And he showed his series and he showed his standard deviation.
I know, man.
No, I take it back. You're not stupid, Witsit. I apologize. That was uncalled for.
Well, it doesn't matter. It doesn't matter what you think.
You're ignorant of the basic math. Ignorance can be taught. Stupidity is forever. Which are you?
Well, you're the one that
Well,
believes in vain religious superstitions.
Yeah, but that's the point. Yeah, and
I
that's
believe
where
in
I
vain
think
religious
that-
superstitions
but
from
I'm
a
trying to be-
priesthood of indoctrination, and then you go around acting like we're stupid if we don't go around like defense attorneys for the system that lied. Weirdos.
Privation is no substitution for education.
I've said on the record, you're not stupid. Okay, by my
Okay,
opinion.
but can we just
So
get to the meat and potatoes?
And I
What you
said
do
it
is
too.
you
You're not
increase the
stupid,
distance.
Witsit.
You have to be
Witsit,
very.
You're not stupid. You're just playing.
Okay, so what he's saying is right. Let's just move on, man. So like what he's saying is right. It's proportionate to the distance, right? And so we need to know the distance, of course, to even know what our window is, our expected window of fluctuation is. Okay, so whenever y'all specify a distance, then we go with that. Distance doesn't really matter, but because you're going to have to increase the distance to really see much of a change, because the Earth is so big. Even if it were a ball, the change isn't very noticeable. It's the noticeable change, or the change itself, is proportionate to distance also, right? Because it's the curvature. It's how much distance you cover. So then you increase the distance to get a noticeable change. You then look at the plumb that you know you established locally, plumbing. It's vertical down, but of course in the ball it's vertical to the ground. I'm just explaining all of it. So it's actually relative to the center of mass. So then you look over there, you have your window. No, I'm just explaining all of it, man. You have the window, right, that you just you expect based on your distance, and then you take the different readings, and then you get an average. You get a mean. Okay? And that's it. So then you take the mean, and then you go and compare it to the standard of comparison. The standard of comparison is the geoid model or the ellipsoid model with the radius value. That's how, so you're like, when he said he was 93% accurate, he's comparing that to the radius value. So he got within 93% accuracy, right? Okay, so you're just taking the apparent location of
You're
what you
mixing
know
up two things that he did, but yeah, I'm with you.
Okay, so you just take the apparent location of where you establish plumb. You don't take all of the readings in the same if one's way different than the other ones, but you take your apparent location, then you get a middle ground, and then you go and try and compare it to what it is, and the accuracy is different all across the board. Right?
In
But
measurement, in measuring, so there are forms of statistics where you will have a bar on your resulting. So you're creating a Boolean distribution, is what it's called. So it's like a bell curve on a graph. Yeah, and anything outside of that bell curve, you're going to discount in your statistical model. This is not the model. No, but this is not the model they use in surveying. That's why I said they use a standard deviation model, which is all results. All results have to be included.
But are they included at the same weight?
Yeah, they're all included at the same weight. There's no weighting on the results.
Okay, well,
So
do you agree that there are some of them that
moving into something called Poisson distribution.
No, you do agree that some of them do have weighted means, though, right?
They don't.
Well, there are some. I've seen them, man.
Then again,
You know, there's
Not
all
even
kinds of
show
geodetic
me and
surveying that's
educate me
been
where I'm
done,
wrong,
right?
and I'm happy to
Okay,
listen.
I'll have to get it, man. But I
Yeah,
didn't just
because
make it up. But it doesn't.
yeah, no,
Okay, there are some that they
I'm not saying
don't
you're
too. Then
right.
let's
I'm
just
not
go
saying
with
you're
those.
wrong. I'm saying at the moment that
Standard
constant,
deviation, you take all of them in. Okay, right? So if you watch the debate,
that
you remember when I
constant
was like, what was the high?
reading.
You remember when, if you watched the debate, you remember when I was like, well, what's the highest you got? You remember I asked him that?
Yeah.
And he never actually came back with the answer. But
No, he showed you the figures. He went back in the slide and then showed you the table of figures.
no, yeah,
And all
no,
those
he
figures
didn't.
had a plus and minus bar on them. And then he worked out his standard deviation,
No.
which was his the tolerance bar from the highest to the lowest value.
Okay, do you agree that within the standard deviation, parallel lies within that window?
No, because his standard deviation was
No, the
0.018.
predetermined. Yeah, you're right on the readings, because all of the readings are based on the distance, man.
Yeah,
Like,
you're
well, come on.
I think your equivocation on that, if I remember rightly, and correct me if I'm wrong, was the standard refraction that he used was the one point you tried to sort of pick on. I think
Well, it's just the refraction in general. Like you're pretending that you're able to come up with a good value for the actual location. And the way you determine what good is literally by comparing it to what's in contention. So it's not like it gets conflated. The reason geodetic surveying is without value is because people use it and invoke as if it does in fact measure the radius itself. It doesn't. It's trying to see how close you can get to it based on the window, and you're looking at distance, and it changes based on distance, bro. It changes based on distance.
Again, short points. Let's keep this nice.
It changes based on distance, man. So like, here's my main premise. Okay, so if there is a ball,
I want to make a point.
Okay, go ahead.
On that because that is why when he went through his explanation, he said, "This is why we're doing it at this altitude. Why I want to be over this altitude is to get out of the dense layers where it's harder to take good account of refraction." So he actually discussed why he raised himself up to that level.
Okay, but this is the thing. When you lift yourself up, you are getting out of the denser layer of the atmosphere. And you can see further when you get higher too, right? We all know that. But then you're still looking down through the thickest part of the
he was doing through a level. So the other point
was high also.
addressing was high also, yeah.
Okay. And okay, you're okay. But you do agree.
The video now because
I'm just so used to Globers not understanding basic concepts. So you do agree that as you increase the distance, although say it's clearer up there because it's not as dense, the more the distance is, then the more atmosphere you have, of course, right?
Yeah, I mean, yeah, that's fair enough.
So refraction is still going to increase proportionate to distance, right?
So what we have to work out is what's the deviation from 7/6R? Is that deviation something significant, or is it the square root of fuck all? And that's the question you need to have answers for, WITSIT.
No. The question is, how do people understand this is insufficient? I'm so confused by it because you're literally just taking the approximation of the apparent location. Now, if you're saying you're trying to account for refraction the best you can by increasing altitude and then increasing distance, well, of course, refraction is still proportionate to distance. So
by necessarily increasing altitude, all he's doing.
No, you're doing both. Like you're doing both.
No, you're not. Why are you doing both? If you're looking straight across, if 1,000 yards at 1,000 yard height is the same as 1,000.
But I'm saying the reason you're doing both in this, because you have to increase the distance to see the difference in angle, because it's just a slight change in angle because it's relative to the whole Earth. It's relative to the center of mass.
It was about 1,500 feet, wasn't it? His
1,500 feet, yeah. And I don't remember his exact elevation. I don't remember his exact elevation.
1,260 meters or feet. I can't remember which it was, to be honest. I suspect it's in feet because he's American.
Okay, so at 1,000 or 1,500 feet, the change isn't even going to be that great, right? Because the Earth is so big. So if the Earth is exactly what they told us, and we're crazy for not believing our authoritative, Nazi-loving Jesuits.
What would be the expected? Just stop bringing in that shit because it's a pointless, stupid thing.
But it's interesting part of it. It's factual. But it's factual though. So
you're being very Eurocentric. We've got a lot of the world that we cover, and your Eurocentrism is not a good look. because it's
Man, I'm not with like the labels. I don't care much about those.
Yeah, I know.
So can we just move on,
Put
man?
them in, and then we'll stop objecting.
You take a fluctuation of the apparent location, you then reverse engineer it into the
What do you mean by
predetermined dimensions of the radius value to get your correction.
So
there is
what do
actually
you
no
mean-
use case for what you're claiming to do for sure,
So
but
what do you mean by fluctuation? Are you just talking about slight differences in the refractive index over day 1 versus day 2, or hour 1 versus
well,
hour 2?
that's part of it, and of course, just the readings themselves are fluctuating. There's a fluctuation of readings themselves, inherently, right? Of course.
Well, no, I mean, we're going to have an accuracy level to the instrumentation, yeah, which is our baseline error bar, but that will be within the standard deviation of the measurements we take by necessity.
Okay, does the total station account for any curvature? It doesn't, right?
I honestly don't know. I don't think so. Not from what I've read. It's not an assumption. The only assumption they put in is the refractive index.
Okay, so how are they interpreting the refractive index if they don't know the angle it's supposed to be at? The computer itself has to factor in the curve.
You know, if you've got a total station, or if you're just using a theodolite, whatever. You know, we're just talking about taking some angles. Let's not talk about what the computer does, because this has been done manually before the computers were invented. That's something from the last 10 or 15 years.
Well, yeah, but the readings are a little different then, but whatever. Yeah, if you want to go all the way back to like the late 1800s or earlier,
No,
I mean,
I'm happy with saying, how about 1979?
1979 they used a theodolite, is what you're saying?
Of course they did.
Okay, and theodolites are less accurate, right?
Yeah.
So we're at a catch-22. I'm not trying to get you or something like.
Now, why don't we go and find out what that difference is? So what the difference in accuracy? Because you're right. You know, if it's like 10 times more accurate.
No, it's nothing like that.
Okay, so if we're talking it's 3% more accurate. Okay, who gives a fuck?
Well, that's a huge deal when you're talking about like supposedly finding the small little change in angle of plumb.
If that 3% is within our error bar. So if it means that that's not going to make a difference to the parallel, versus non-parallel plumb lines, that's what you need to understand, or what we need to understand, because I don't know the answer to that.
Well, I'm pretty sure that like modern computers, they factor in the curvature over vast distances to get the readings, but maybe not. I'm pretty positive they do because
I doubt it.
there are some computers that do, but I don't know that they all do.
We're talking difference between total station and someone doing computer modeling.
But they're like total stations where they have like computers.
Yeah,
I don't know if they're okay.
But they're not going to be the type of thing that's going to say, hey, we've got all these things we're going to assume about the world, and this is how we're going to affect our actions.
Well, geodetic surveying is assuming the Earth's a sphere, dude.
It's going to be a way of logging that data, the same way as you log data on pretty much any electronic instrument.
No, you have to
And
understand.
then I can probably export it out as an XML or a CSV, and then I can import it into my database, and I can start working on those results.
It imposes.
That's normally where we're going to do any assumptions that we're going to have.
If there's a computer, it imposes curve, man.
No, that's a lie.
Okay, well, that's what the geodetic surveyor dude said.
I don't think it necessitates that if there's a computer, it means it's taking into account curvature. He could say that this particular model does, but I doubt that's true for all of them.
Well, he didn't say a model though, but okay.
So
he did say he compares it to the NSDA or NDSA. What?
So why don't we find out? We could go and look at specifications, see if we can find out in there. We could get empirical evidence rather than guessing.
Yeah, because I agree.
We're relying on someone else's anecdotal information. So why don't we be skeptical rather than assumptive?
Well, that's my point. Like, I'm being skeptical of all of it. Like, I want to narrow down and get the best postulation. Like, because what Glover wants to do is invoke all of it, but you can't invoke all of it. We've narrowed it down numerous times throughout the discussion of what's inefficient. And Glovers want to skip over inefficiencies and then tout them as if it makes them smart because they know how they understood the procedure or whatever. And it's annoying. So we have to make sure we get rid of these presuppositions that are the very thing that people are claiming this is invoked to prove. So almost all geodetic surveying is off the table from the rip because it's literally an act of comparing the known dimensions. Now, if you're looking at, you can say that the plumb and then the differential of things and small things prove it, then we can talk specifically.
I think you're making an assumption there. I don't think that's something you know as a fact.
No. It is, though, because if you increase distance and you have a point to point, right? That's totally different if the Earth's a ball, man. Like, there's an arc length there, dude. As you increase distance over 12 kilometers, you're going to have to account for the fact that, in fact, that line from point to point is, in fact, curved. You're going to have to know the arc length.
I don't think geodetic surveying arbitrarily assumes the Earth is a globe.
No, it doesn't arbitrarily. It assumes the R value accurate, man. We've been to space, bro. What are you talking about?
It's the fact that it's based on prior evidence.
Okay, but it is definitely based on the R value. And it's also based on gravity, based on that. That's what geodetic surveying acknowledges. The whole point is geodetic surveying acknowledges that although we got plumbed up, it isn't actually just vertical in general. It's just vertical relative to the center of mass. That's what geodetic surveying is. It's acknowledging that distinction.
I like that silence.
Yeah, I feel I've taken way too much of my time, and I think I've kind of made the points that I want to make. But I felt really in that conversation, I was being more of the skeptic.
I'm just skeptical of the entire postulation being invoked, that this somehow measures. This is the big thing, man. This is a calculation. This isn't a measurement. And if we could just all come together and be honest and answer that and acknowledge that, we didn't measure the radius. You're not doing it by doing this. This is a calculation based on a convexity rate, and it's using the ellipsoid.
It's measured, sorry.
Well, okay. You're just wrong.
I mean, he's to broom something. Yeah. You gotta get him to do stuff.
Hi, Mikey.
I mean, he should just sweep the floor.
Hey, bro, you're hot miking El Baruca.
My bad.
I don't want to sweep the floor.
WITSIT, you need to add a few anti-Semitic tropes. I'm trying to get bingo here.
Okay. Isn't it convenient that we supposedly are all divided based on blue and red and politics, but they disagree on everything, but they all seem to agree on one thing, and it's undying allegiance to the state of Israel. 1/3 of our foreign aid budget, in fact, goes to Israel, even though they make up 0.0001% of the population.